Hello and welcome to this lecture on vector calculus. In this video, we are going to solve a problem using Green's theorem. So let's begin. So first we see about the statement. If P of x comma y and q of x comma y are continuous functions with the continuous partial derivatives. So if I take two functions, that should be a continuous, and of course there should exist a derivative with respect to x and y. So we used to say that is partial. In the region R bounded by a simple closed curve, then the line integral will be equivalent to the region. This line integral will be equal to the region or surface integral. Okay, so what the statement says here, in the form of p dx plus q dy, this line integral, instead of evaluating this, we can evaluate the double integral with respect to x and y over the given region. If sometimes in the problem, if they ask to evaluate any of line integral with this type of formation, then we can use this Green's theorem and we can evaluate that problem by using a double integral. Then we can find the solution. Sometimes they may ask the RHS part in the form of RHS part, then when we can go for the line integral part. So it gives the relation between a line integral to a surface. Okay, a region, line integral to a region. Then here C is transferred to a counterclockwise direction. Counter means that is anti-clockwise direction. Okay, so now we are going to solve the problem. Here they have given a line integral, the x square into 1 plus y dx plus x cube plus y cube dy. So clearly, if they ask to verify, you have to find both LHS and RHS of the given statement in Green's theorem. If they ask for any evaluate, if they have given only the line integral, you can use the double integral to evaluate this problem. Okay, if they ask for the evaluation in double integral, you can use the line integral to find the solution for that problem. So now they have asked for the verification. So what we have to do, we have to find both LHS and RHS part. So for that, what is our statement? It is of line integral p dx plus q dy. So here this will be the p and this will be the q. So here p will be x square into 1 plus y and q will be x cube plus y cube. Okay, now we want to evaluate the RHS part first. Now to evaluate the RHS part, we need dou q by dou x and dou p by dou y. So we need dou p by dou y and dou q by dou x. If I differentiate the p with respect, it can be written as x square plus x square y. If I differentiate this function with respect to y, this term becomes 0 and here it will be of x square. And if I differentiate this function with respect to x, it will be 3x square. Okay, so we will find the p and q from this and we will find the derivative. Then what we want to do? We want to go for the evaluation. So in the Green's theorem, this line integral will be equivalent to the region, and here it will be of dou q by dou x minus dou p by dou y. So I am substituting the values here. Then 3x square minus x square, it will come 2x square. So and also they have given the curve C. So x will be equal to plus 1 and x will be equal to minus 1 and y will be equal to plus 1, y will be equal to minus 1. This is the curve. So with this we want to find the limits with respect to x and y. So we have to draw a region by using this equations. So this is the region. So here clearly it will be of y equal to minus 1. This line will be of x equal to 1. Here y equal to 1. Here it will be of x equal to minus 1. So we have drawn a region. Okay. So first of all, after drawing a given equations, we have to note that it always moves on the anti-clockwise direction. So here I am starting at the point A as minus 1 comma minus 1. This has to move on the anti-clockwise direction. Okay. So with this region, that transverse counterclockwise direction will be of A to B, B to C, C to E, D to A. Next, we will take over the given region. How do we find the limits for it? What they have given? Dx dy. Dx dy. So, in integral calculus, we have studied about that. In dx dy, it represents the horizontal strip. So, just draw a horizontal strip. Or else you may easily assume that x moves from minus 1 to plus 1, but I am showing that how it comes. First, and with respect to dx dy, I have drawn a horizontal strip. So in horizontal strip, now we want to see the limits from left to right. Left to right. So left end, here this equation will be of x equal to minus 1, and right end here the equation will be x equal to plus 1. So if it is horizontal strip, now first we want to find the limits of the parallel axis. Horizontal strip is parallel to y-x axis. So first we will find the limits for x axis from left to right. So the lower end of x will be minus 1 and the upper limit will be plus 1. Now this is the region. We can clearly say that y varies from minus 1 to plus 1. So here y is minus 1, y will be plus 1. This is the direction, no? So it moves from down to up. So minus 1, y equal to plus 1. So that only we get the limits of x from minus 1 to plus 1, and the limits of y is also from minus 1 to plus 1. Now we want to evaluate this. First we will evaluate the inner integral. We will evaluate the inner integral. Means first I will take the inner integral. 2 will be a constant. X square dx will be there. So here it becomes x cube by 3. X cube by 3 minus 1 to plus 1. So then 2 by 3 will be a constant. 1 minus of minus 1. So it becomes 2 by 3, 1 plus 1. So totally 4 by 3. So we find the 4 by 3. I have find the inner integral as 4 by 3. Next I am going for the outer integral with respect to the variable y. So we want to integrate this with respect to y. So I may keep 4 by 3 as constant and I am integrating the y. So it becomes 4 by 3, y will be there, minus 1 to plus 1. So 4 by 3, 1 minus of minus 1. Here it will be 4 by 3, 1 plus 1. So 8 by 3. So I have evaluated the double integral, then I am getting the solution as 8 by 3. So therefore RHS of the Green's theorem is 8 by 3. Now we are going to evaluate the LHS part. So this is the problem they have given, and we have drawn a graph with the given regions. This is the graph. Okay. So here we want to break C. This is the curve C, totally a C. 4 into 4 segments. I am taking each of the line A, B, B, C, C, D, D, A. Okay. So along A, B, first I will take this line alone. What's the equation here? X equal to, y equal to minus 1. So here the equation is y equal to minus 1. If I differentiate this equation, the constant, if I differentiate constant with respect to y, it becomes 0. So dy becomes 0. And here from this point to this, from A to B, x varies from minus 1 to plus 1. So minus 1 to plus 1. So with this, I want to substitute these values. So this will be the limit of x. Here, if I substitute dy equal to 0, no, this whole term becomes 0. This becomes 0. And y equal to minus 1, here it will be of minus 1. Okay. So on the next part, minus 1 plus 1, it becomes 0. So this whole thing becomes 0. And here it is plus 1. If I substitute minus 1, the whole thing becomes 0. Finally, along AB, I am getting the value as 0. I am substituting the value for x from minus 1 to plus 1. That's because we have only one integral. So I am substituting this whole thing becomes 0, that is a dx. So we want to substitute the limit for x. Okay. So now I am going for the line BC. So here BC means here it will be x equal to plus 1. So I am taking x equal to plus 1. If I differentiate this, dx will become 0. And from this B to C, here see dx becomes 0. That means this whole term becomes 0. This whole term becomes 0. Okay. So what we want to do? We want to find the limit for y. So y varies from minus 1 to plus 1. So y varies from minus 1 to plus 1. And I have to substitute these limits to the given problem. And I will get the value as 1 cube. X will be 1, 1 cube. Y, I don't know the value of y. I know only the limits. So minus 1 to plus 1. Y cube will be there. Then 1 plus y cube dy. Then we can split the integral. It is a constant. So I may keep it as a constant. So integral dy plus integral y cube dy. So this becomes y minus 1 to plus 1. And here y power 4 by 4 minus 1 to plus 1. So here it becomes 1 plus 1 because y minus of minus 1 becomes 1 plus 1. So this part gives 2. And here, what about this? Here it will be 1 by 4 minus of here minus 1 whole power 4, it becomes plus 1. So 1 by 4 again. So this whole part becomes 0. Here it will be of 2. So finally I am getting 2. Okay. Next I am going for CD. So I am going for CD. So in this, what is the equation of this line? Y equal to plus 1. So I am taking that y equal to plus 1. If I differentiate this, becomes dy equal to 0. And here dy becomes 0. Now I have to find the limits for x. X varies from plus 1 to minus 1 because this is the direction. Plus 1 to minus 1. So plus 1 to minus 1. I am going for the evaluation part. I am just substituting all these things in this given equation. Dy becomes 0. Now this whole thing becomes 0 and y equal to 1. So 2x square will be the term. And I am taking that. Here see plus 1 to minus 1. I have changed the limits minus 1 to plus 1. If I change the limits, I have to equate to minus. So I am adding the minus over here. Okay. So I am taking the constant 2 outside. Then I am equating that integral x square. Integral x square becomes x cube by 3. Then if I substitute the upper limit to the lower limit, now I am getting the final value is minus 4 by 3. Okay. Similarly, last I am taking the line dA. Here the equation will be x equal to minus 1. So x equal to minus 1. Then if I differentiate this, it becomes 0. dx becomes 0. Now this whole thing will be 0. This is the function. I have to find the limits for y. Y varies from 1 to minus 1. So 1 to minus 1. So I am substituting all these things in the given problem and I am getting the function as minus 1 whole cube. Minus 1 whole cube, now it becomes minus 1 and y cube will be there and I have to integrate this. So I may do the same thing. I am interchanging the limits. I may put minus over here. So here integral of minus 1 becomes plus 1. Dy will be there and minus integral of y cube dy. I may split the integral. And here it becomes 1 minus 1. It becomes 1 minus of minus 1. It becomes 2. And if I go for this value, here y power 4 by 4 will be there. And usually if I substitute the values, I will get 0 as like the previous case. So finally I am getting 2 alone. So finally we have evaluated the line integral for each of the line AB, BC, CD, DA. So with this 4, while adding up all the 4 values, I am getting that 8 by 3. So I'm taking this as equation 2. If you go for the RHS part, what we have evaluated, I'm also getting that 8 by 3 here, and this is the LHS part, I am getting the same value. So hence it is proved. So the line integral matches the surface integral. Therefore Green's theorem is verified. And then I am adding one more problem as exercise. You just practice this problem. Here the same type of problem. They have given a line integral. This will be P and this will be Q. Okay. With this we have to verify. Verify you have to find both LHS and RHS part. So here I have given the limits. With this we have to draw a graph. X equal to 0 means it will be y axis. Y equal to 0 means it will be x axis. If I put in this equation, if I put x equal to 0 means you will get y. X equal to 0 which gives y equal to 1. And if I put y equal to 0 which gives x equal to 1. So I am getting the value of point 1 comma 0 and 0 comma 1. With these 2 points we can join the line. So finally this will be the answer and this will be the graph. The x equal to 0, y axis. Y equal to 0, it is x axis. 1 comma 0 and 0 comma 1. And I can join the line. It will be like a triangle. So this is the region. What they have given here, PQ. With this, we have to evaluate RHS part and you have to evaluate LHS. Finally, both has to be equal. If it is equal, then hence it is verified.